The stars. Stars are the most numerous objects in the sky, other than maybe mosquitoes on occasion. On a clear night, from a fairly dark location, you can see about 3,000 stars with your naked eye. Binoculars and telescopes will reveal tens of thousands more. All of the stars you see belong to our own galaxy, the Milky Way. Take a look at the stars on the next clear night. Aside from the difference in brightness from star to star, you'll also want to notice the difference in color. Some stars like Rigel in the constellation Orion are blue. Others like Altair and Aquila are white. Arcturus, a bright star in the northern spring sky, is yellow-red. Yet others, like Betelgeuse in Orion or Antares in Scorpius, are a deeper shade of red. The color differences are real. Just like the hot coals of a fire glow red, hotter coals glow white, the color of a star depends on its temperature. Red stars are the coolest. They have a temperature of around 4,000 to 5,000 degrees at their surface. Yellow-white stars like our Sun are hotter at about 6,000 to 10,000 degrees. And blue stars are the hottest of all, with surface temperatures of 15 to 30,000 degrees. Blue stars are massive, some 5 to 10 times the mass of our own Sun. Massive stars burn hottest and emit most of their light in the blue and ultraviolet part of the spectrum. White and yellow stars are young to middle-aged, mid-sized stars. Most of the red stars you see were once massive blue stars that are getting near the end of their lives. And most of the stars of the galaxy are dim red stars, much less massive than our own Sun and too faint to see without a large telescope. Some stars look bright because they are bright. Others appear bright because they're close to us. Deneb, the brightest star in Cygnus, is one of the brightest stars known at about 60,000 times brighter than our Sun. It's 1,500 light years away. 1 light year is the distance light travels in 1 year, or about 9.5 trillion kilometers. Sirius, on the other hand, appears a little brighter than Cygnus, but it's only 25 times brighter than our Sun, and only 0.4 ten-thousandths as bright as Deneb. But it appears brighter because it's closer, 175 times closer. That's just 8.6 light years away. Star clusters. Stars form from clouds of dust and gas that pull together by the force of their own gravity. Stars usually form in groups of dozens or more out of clouds of gas and dust along the plane of the Milky Way galaxy. As the gas clouds condense into dark globules, it heats up and eventually starts a process called nuclear fusion that releases huge amounts of heat and light. When fusion starts, each globule within the immense cloud of gas and dust becomes a star. Dozens of stars are born roughly at the same time in a small cluster. These groups of newborn stars are called open star clusters, since they form a fairly loose collection of stars that eventually disperses into the galaxy. Open clusters are one of the most beautiful sights in the sky for binoculars or a small telescope. You may have seen at least one already. The star group called the Pleiades is an open cluster of new stars less than 1/10 the age of our own Sun. Hundreds more such clusters lie within the reach of a modest backyard telescope. Globular clusters. Globular star clusters are another favorite of stargazers. But unlike open clusters, globular star clusters are immensely old, in the range of 10 to 13 billion years. Now that's nearly as old as the universe itself. Globular clusters contain tens of thousands of stars. That's many, many times more stars than found in open clusters. But they're located very far away in a vast halo around the nucleus of our galaxy, so most of them don't appear very bright. Only 3 are visible to the naked eye: M13 in Hercules, 47 Tucane, and Omega Centauri. Of these, 47 Tucane and Omega Centauri can only be seen from the southern hemisphere. A small telescope will show you dozens more of these ancient jewels. Nebulae. A slow pan with a small telescope along the plane of the Milky Way will reveal many faint fuzzy patches of silver-white light that glow against the velvety night sky. We call these diffuse nebulae. Made from gas and dust lit by stars formed in their mist, diffuse nebulae are the stellar nurseries of the galaxy. New stars form out of collapsing clouds of dust and gas. The new stars excite the atoms of the gas that remain in the cloud. The atoms emit the light that you see. In time, as the gas clears, an open star cluster will take the place of the nebula. The sword of the constellation Orion contains one of the brightest and most famous nebulae. You can see it as a faint, fuzzy patch of light. A telescope reveals an amazingly beautiful view of the Orion Nebula. You can see more diffuse nebulae such as the Swan, Lagoon, Trifid, and Eta Carina nebula, even with just a pair of binoculars. A planetary nebula is another common sight for stargazers. Very different from a diffuse nebula, planetary nebulae are named after their appearance as a small disk that somewhat resembles a planet. These nebula are the last gasp of a mid-sized star that's exhausted all of its fuel. The stars at the center of each planetary nebula are ejecting their atmosphere before they settle down as their final stage of life, a white dwarf. Our Sun will end its life as a planetary nebula in about 5 billion years. There are no planetary nebulae that can be seen with the naked eye, but hundreds are visible in a telescope, including the Ring Nebula in Lyra and the Dumbbell Nebula.